Okay, this is chapter 10 in your book. It's called Sequences and Series. In mathematics, a sequence is an ordered list of numbers called terms. The terms are often arranged in a pattern. Okay? The three dots, called an ellipsis, indicate that a sequence is infinite. So it's continuing on, so on and so forth. A finite sequence is one that ends. It has a last term. It says find the next two terms of the sequence. Well, here, what are we doing every time? We're adding 2. We have a common difference of 2. So the next two terms would be 12 and 14. This one, we are multiplying by 2. So we have a common ratio of 2. So it would be 64 and then 128. The next one, we are adding a -3. So the common difference is -3. So the next two terms are -10 and -13. Here, we are multiplying by a -3. So the common ratio is -3. And the next two terms would be -729, 2,187. We are just going to focus on these two types of sequences. Ones where you add and ones where you multiply. There's some where you add and multiply. Okay, but we're not concerned with those. The ones where you simply add or have a common difference is called an arithmetic sequence. Look at the following sequences. What are the patterns? Adding 4, multiplying by 2. Example 1 is different from example 2. It differs exactly by the same number, and this is called an arithmetic sequence. An arithmetic sequence is a sequence whose successive terms differ by the same number, D, called the common difference. Okay, so arithmetic, successive terms, so one after the other, they're going to have the same number, a common difference called D. Okay, so that's arithmetic. It says, are the following sequences arithmetic? Well, this first one, you're adding 3 every time. So yes. This one, there's no common difference. No. So it is possible to write a formula for a sequence. A sequence can be defined by a recursive formula. So it can be written as a formula, but today we're going to focus on recursive formulas. There's going to be other ones. With this one, you use a previous term to generate the next term. So notice every time we're subtracting 2. Okay? So every time you have a term, you subtract 2. You subtract 2, you subtract 2. Our first term was 1. So if you're trying to find term 2, you take term 1 and subtract 1. To find term 3, you take term 2 and subtract 1. To find term 4, you take term 3 and subtract 1. To find term 5, you take term 4 and subtract 1. To find term 6, you take term 5 and subtract 1. But we don't want to write term 6. We want to find whatever term we're trying to find. We call that our nth term. If we're trying to find term n, we're going to take term, not n, but one lower, n minus 1, and we're going to subtract 1. So whatever term you're trying to find, you take the previous term and subtract 1. So this is your formula. But you need to give the reader something to work with. So you say, this is your formula. Or I guess it's not subtract 1, I'm sorry, it's subtract 2. This is your formula. You start with the second term because you can't start with the first term because you need something to work with. So you're saying this is your first term. You start with your nth term being 2, and then there's your formula. It says go back to example 3 and write a recursive formula. So looking at example 3, your first term is -3. You're always going to start with your second term, but you have to tell the reader, hey, n has to be 2 or greater. You either have to start with your second term or third term or fourth, whatever, greater. And your term n is going to be found by taking the previous term and adding 3. So we have our 3 things. Our first term, where we should start in the formula, and your formula. Okay. Now we have a formula, and they want us to find the first 6 terms of a sequence defined by this formula. So we're going to take the recursive formula is to find whatever term we're finding, take the previous term and add 3. Start with your second term. By the way, your first term is 4. So they want to find term 2. If 2 is n, 2 minus 1 is term 1 plus 3. I could write all that out, or I could just say, all right, term 2 is the previous term plus 3. Term 3 is the previous term plus 3. Term 4 is the previous term plus 3. Term 5 is the previous term. Oops. Term 5 is the previous term plus 3. And term 6 is the previous term plus 3. So let's see if we did that right. It should be 4, 7, 10, 13, 16, 19. Yeah, we're adding 3 every time. Okay, so do we have to do a ton of work to do that? No, we could just say we're just adding 3 every time. All right, now let's talk about geometric sequences. So arithmetic is when you add it every single time. Geometric, okay, is when there's a ratio of successive terms. So a geometric sequence is a sequence in which the ratio of successive terms is the same number r, called the common ratio. Are the following sequences geometric? Yes. Common ratio is 2. Yes. Multiplying by a third. Division is a common ratio. You're multiplying by a third. Okay. Recursive formula for geometric. So we're going to do the same thing. What's your first term? You start with the second term. And here's your formula. To find the nth term, you're going to do something with n minus 1. So let's start with this one. Your first term is 3. To find 6, you had to take your previous term and multiply by 3. To find your third term, you had to take multiply by 2. To find your third term, you had to take 6 and multiply it by 2. To find your fourth term, you had to take your previous term, multiply it by 2. So you could write it like this, or you could say 2 times your previous term. And we're going to do the same thing here. Your first term is 27. You need to start with the second term because you're going to use the first. So if I'm trying to find whatever term, I take the previous term and multiply it by a third. So you can leave it like that or say whatever term you're finding, it's a third of the previous. It says review. I want you to pause the video and try these on your own. It says, are the following arithmetic, geometric, or neither? If arithmetic or geometric, state a recursive formula. So I'm adding 4, I'm adding 8, I'm adding 16. So you're adding different amounts every time. There is a pattern, it's just not arithmetic. So you just say neither. This one says you are adding 4 or subtracting 4 every time. So your common difference is -4. So your first term is 2. You want to start on the second term. And your formula is whatever term you're finding, you're going to take your previous term and subtract 4. Write the first 4 terms. Okay, so if you want term 1, you substitute in 1 here. 16 plus 3 times 1 is 19. This is not a recursive formula, but that's okay. Term 2, you substitute 2 in. 16 plus 6 is 22. Term 3, 16 plus 9 is 25. Term 4 is 16 plus 12, which is 28. Term 5, put 5 in, it's going to be 15, 31. And term 6, oh, they just wanted 4 terms. All right, we're done. Here, term 1, it's going to be 2 times 1, which is 2. Term 2 is going to be 2 times -3, because this is to the first power, which is -6. Term 3 is going to be 2 times -3 to the 3 minus 1. So it's going to be 2 times -3 squared, which is 9. It's going to be 18. And you start to see a pattern of multiplying by -3. Term 4 is 2 times -3 to the 4 minus 1, which is 3. So if you multiply that by a -3, because it's making that back and forth, you get -54. Last one, term 1, all that squared, you get 4. Term 2, 4 squared is 16. Term 3, 6 squared is 36. Term 4, it's going to be 8 squared is 64. Okay, they want to know if they're arithmetic, recursive, or neither. It should be geometric. So you're adding the same number every time. It wasn't a recursive formula, but yes, it's arithmetic. Here you're multiplying by -3 every time, so it's geometric. And here it changes every time. It's also a quadratic, so neither. Okay, so that's like a recap. If you can do all this, then you got the lesson. We have one more small part, and then you're done. Arithmetic and geometric means. It says arithmetic means are the terms between any 2 non-consecutive terms of an arithmetic sequence. So if I start out with 24 and there's 4 arithmetic means, it means that there's 4 numbers in between 24 and 39. Students can usually figure out how to do this. So why don't you try, pause the video, and figure it out. Notice I'm going to have a common difference every time. You don't know what that common difference is, but it's going to be added, and then added, and then added, and then added, and then added. So if I have 4 arithmetic means, that means I had 5 common differences that I added. So I went with 24 and I started to add 5 common differences. When I solve, my common difference is 3. So my numbers are 27, 30, 33, 36. Yes. Okay. All right. Find 5 arithmetic means between the numbers. Okay, so once you try this one, same process, and then check back. Okay, so your common difference was 2. Make sure when you hit that last number that jump is also a -2. Example 8, find the 4 geometric means between 4 and 972. Well, now you're multiplying because it's geometric. So you took 4 and multiplied by an r every time. So 4 times r times r times r times r times r equals 972. That's the same thing as saying 4 times r to the 5th. When I divide both sides by 4, I'll get 243. And then when I take the 5th root, I get 3. So how do you do this? In your calculator, you type 5, you hit the math button, you go to this asterisk that's in the index part of the radical, and you hit enter. This 5 represents that star, so it'll be a 5th root. All right, so you took the 5th root and you got it was 3. So then you go back. 4 times 3, you have 12, times 3 is 36, times 3 is 108, times 3 is 324. Okay, so it's not hard. That's how you find them. All right, I want you to try the last one on your own. Guarantee no one will get it their first shot, but try it. All right, so you get 5. You multiply by 5, you multiply by 5, you multiply by 5. Make sure that jump is there, multiply by 5. Where students mess up is they forget, oh, it could have also been -5 because it's an even root. And -5 times a -5, 25, times a -5, 125, times a -5, 625. So if I did that, I would have gotten -60, +300, -1500, +7,500. So your answer should be positive and -60, 300, positive -1500. Okay, this number wouldn't be positive or negative because when you multiply by negatives, it goes every other. So make sure you don't forget that part. Okay. All right, that's it for this lesson.